Okay, we now have air and hydrogen plumbed to the GC. The hydrogen generator is coming to an operational condition. What does that mean? It means that the electrolysis is occurring and the hydrogen pressure is coming up. The air pressure is being fed to the instrument, and the catalytic cleanup system on the zero air generator is warming up. And we have about 30 minutes before we'll be able to actually start the instrument. In the meantime, suppose you were in a laboratory and you had these facilities from either tank resources or your laboratory supply line. You just go directly to start up. And recall, we have connected all the lines on the side. Use your normal laboratory practices and process practices for checking for leaks throughout the whole system, which we have done. And what I'm going to do is switch on the power on the side, and you get a startup display, basically the boot routine on the main computer board. And you can see it's coming into an operating condition. You hear the fan has come on. And the home screen on the touch screen display enables you access to the controls and the operating condition of the gas chromatograph. For example, this button called Snapshot enables a screen that tells you the condition of each of the modules that are installed. Again, this is CALIDUS 101, so there's a single column, a single detector, the injection oven or sample processing module that we talked about earlier. And what you get is operating temperatures and pressures and whether or not they're up to operational condition. And you can see the Ethernet is not ready yet. We haven't made the proper connections to that, and we'll do so in just a little bit. This home button always takes you back here. And for example, you can look at the isothermal zones. And when we plug a method in and download the method, what you'll see is the red bars will progress from left to right. You see the temperature set points on the right-hand side here, and once CALIDUS is up into operating condition, these bars for the injector, the detector, and will progress and be red on both sides. So we go back to home. Those are the isothermal zones. The columns are not isothermal, although they can be operated in an isothermal mode. And what you see here is a profile of the column 1 temperature program. We also have pressure programming on this instrument, and you can see it's a flat line, meaning that there is no pressure program in this particular method. So that pretty much shows you what's expected to happen with the instrument during its method. The control of the modules. You can see there's one column, one detector, and the injector oven. And basically, when you have a look at that, it shows you the operating condition of the column module itself. Everything's turned off at this point. The pressure temperature program profile is shown here in this part of the screen. This is a smart instrument in that it identifies the column type. This happens to be a MXT-HT, standing for high temperature. It's 2 meters in length. It has a film thickness of 180 microns, an inside diameter of 180 microns, and the film thickness is 0.4 microns. And this particular column has had 265 cycles run on it. You can see that the software version is here. The temperature of the instrument currently, and at its set point, it's set for 40 degrees C, and it's currently at 19.2, and it's turned off. And if you look at the again, the detector, same kind of thing. Turn on the air, turn on the hydrogen, turn on the temperature, the software version, the number of cycles that have been run on this particular detector. And again, we look at the injection module, and that shows the operating condition here, the various things to turn on, for example, temperature and the pressure for the carrier gas. You're able to set the split rate, split vent flow here. And during setup, you tell it which modules you're going to operate, and even to the point of saying, I want to set the IP address for the Ethernet port on the instrument. And if we go back to the home, the instrument is fully internet aware. Software versions can be updated I'm not going to push the button because it basically says I'm waiting for somebody to send me new firmware, and we don't choose to do that right at the moment. So we're pretty much ready to go. We have to take care with some gas controls. The instrument is shipped with the needle valves turned off. They're already set for the flow rate, and in order to get ready to do operations, we simply need to open the needle valve fully, and the center set screw is set for the proper flow conditions. And now we're pretty much ready to begin heating up the instrument, applying the carrier gas when the hydrogen generator is ready to go, and we're about ready to start up the GC.